Here they say that you have a solid cylindrical wheel with a mass m and a radius r that they give to you in centimeters. You need to convert that to meters. And it starts from rest, so that means omega naught equals 0, and rotates about its axis with constant acceleration. So we have some angular acceleration alpha. They talk about some time t that they give you, and they say that after a certain time t, it's rotated through a certain angle theta, which they give you in radians. That's the right units. So if we decided that that's what theta is, that means we've decided that theta naught equals 0. So the first question asks you what the angular acceleration is. So we're looking for this angular acceleration here. What is it? Well, we know that angular acceleration can be found from torque equals I alpha, but they didn't tell us the torque, so we can't use that. So that means we probably need to go to kinematics. And you know my favorite kinematics formula is always the one without squaring in it. Omega equals omega naught plus alpha t. And here we know what omega naught is, that's 0. We know what t is, but alas, we don't know omega, so we can't use that one either. We need the one that has thetas and t in it, but no omega. So that one's going to have to be theta equals theta naught plus omega naught t plus 1/2 alpha t squared. And we know that theta naught is 0. We know that omega naught is 0. So we just have theta equals 1/2 alpha t squared. And so that means that alpha is going to be 2 theta over t squared. And we can plug the numbers in and get the answer. For part B, they ask you what the angular velocity is after another amount of time. Well, now we can use my favorite equation, omega equals omega naught plus alpha t. We know omega naught's 0. We just found alpha from part A, and we had t from a new t was given to us for this part of the problem. Part C asks us to find the centripetal acceleration. Well, we know that centripetal acceleration can be calculated as v squared over r or omega squared r, whichever one we think is easier. And we know that we know omega and we don't know v, so let's use omega squared r. We have omega from the answer to part B, and the r, they gave us a certain distance away from the center in the problem, so r is going to be the r from this problem, from this question. Mine's 3 centimeters.